Assalamualaikum and hi to our beloved lecturer for Fluid Mechanics, Sir Mahmud. My name is Ashraf Hakim bin Muhammad Johan and my matrix number is AA200491. We are from Section 6 Group 2. Me and my group members, which is E. Minchi, Ikhwan Hanif and Diana Nabila, will present about the first topic of the experiment, which is flow rate through a Venturi meter in a pump system. This presentation contains 6 contents. Every of them will present their part. I will begin with the objective of the experiment, but before we begin with the objective, let me tell you the learning outcomes of this experimental. At the end of the experiment, we should be able to understand the relationship between the flow rate and pressure with respect to a Venturi meter and how the Bernoulli equation is applied. So, the first objective is to measure the flow of a fluid through a pipe, and the second objective is to increase the velocity of any type of fluid in a pipe of any particular point that works on the principle of Bernoulli equation. Now, I will proceed to the additional theory. The Venturi meter is a device which is used to measure the discharge of a long pipe. The fluid following in the pipe is led through a construction section through a throat, which has a smaller cross-sectional area than a pipe, so that the velocity of a fluid through the throat is higher than in the pipe. The increase of velocity is accompanied by a fall in pressure, the magnitude of which depends on the rate of flow, so that by measuring the pressure drop, the discharge may be calculated from the equation Q theoretical equals to A1 plus A2 times to the power 2GH1 minus H2 over square root A1 square minus A2 square. We will get K times square root H1 minus H2.
Assalamualaikum, my name is Diana Nabila Tasha binti Hamdan, my matric AA200381. For equipment, first, Venturi meter. Venturi meter is a flow rate measurement meter. Second, H47 centrifugal pump test set. The bearing-mounted motor drive the pump, which is powered by a self-contained water source. During cavitation, students may witness the impeller turning and the creation of water vapor bubbles through a glass window.
Hi and good day, my name is Imiji and I will explain about the procedure for this experiment. For the first step, before we start the experiment, we make sure that the delivery valve is fully open and the inlet valve is fully closed. Step 2, the main switch and the motor drive isolator are switched on. The start button is also pressed on. Step 3, we open the pump inlet slowly at low and half opening. We increase the speed slowly by rotating the motor control, and we open the inlet valve at full opening before the speed reaches 1000 rpm. Step 4, we increase the speed to 3000 rpm and ensure that there are no bubbles in the pump. The pressure line is checked to ensure that there are no bubbles inside. If there are any bubbles, the blade line is used to blade all pressure gauge. Step 6, when the system was stable, the P1 and P2 reading were recorded. For the next step, the inlet valve is decreased to vary the value of P2 at every 0.05 bar. The steps are repeated to obtain 6 sets data. For the last step, at the end of the experiment, the speed is slowly reduced and the inlet valve is fully closed. Then the motor pump and the main power supply were switched off. That's all from me. Thank you.
For discussion, the graph shows P2 versus Q and P1 versus Q. The graph depicts the linear relationship between flow rate and pressures. We can see that as the flow rate decreases, so do the values of P2 and P1, which means that when the flow rate increases, the head loss decreases, and as the velocity increases, the head loss decreases as well.
Assalamualaikum, my name is Ikhwan Hanif and my number is AA200784. So, in this video, I'm going to tell about the conclusion of the experiment 1, which is flow rate through a Venturi meter in a pump system. So at the end of the experiment, we can see there are relation between the flow rate and pressure in the Venturi meter. So we use the Bernoulli equation for the experiment to calculate the velocity of this fluid. The result of this experiment came out consists of two different results, which is experimental and calculated. After we get the experimental and calculated, we create the graph for P2 versus Q and delta P1 versus Q. According to the boost graph, we can see the trend of the graph shows the decrease linearly. At the end of this experiment, the aim of the experiment came out as we expected. In the experiment also, there are various challenges that we have to face. For example, we want to get the 3000 RPM, but it was difficult to reach the exact value, so we take the slightly above and slightly bottom of the 3000 RPM. So not also that in the experiment we have to avoid the form of bubbles, but during this procedure there are bubbles formed in the system. So how we get it is we follow the instruction of the video that given to us before we started the experiment. I think that's all from me and my friend. Hope you understand what we try to give to you.